introduction. Well, good morning, depending on where you are in the world, or good afternoon or good evening. It's morning for me. I'm in Spain at the moment, so it's 10 o'clock in the morning for me, but in the UK it's 9, and I know that our audience today is very much worldwide and global. So welcome to the Getting Ready to Teach International GCSE Mathematics. So this session is going to give you a flavour of what Pearson have to offer. We're only going to concentrate on 2 specifications. That's Specification A, that's for MA1, and Specification B, that's for MB1. There is a 3rd specification that Pearson offer for international GCSE, that's further pure maths, but we will not be touching that at all today. So I'll tell you a little bit about myself. I'm a retired teacher. I taught in fact, I came late into the teaching profession. I didn't start teaching until I was in my early 40s. And my only regret is that I didn't start it a little bit earlier. I absolutely loved it in the classroom. And I taught throughout the age range from year 7, that's 11-year-olds, up to further maths A-level. I taught children who are extremely able, and I've taught children who find maths very difficult. And the pleasure in teaching them is exactly the same. It makes no difference. I did find the classroom absolutely wonderful. I was in a state school for 14 years. I was head of department there. And then after that, in fact, when I was 60, I decided that I'd need to just take it a bit easier. So I went to then a college of further education. And in the UK, there's different types of colleges, but the one that I went to is a vocational college. So all of our students at college were training to be hairdressers, carpenters, electricians, to work in the hospitality sector, to work in health and social care, etc., etc. And most of them were non-academic, and most of them had not actually achieved a grade C or a grade 4 as it is now in GCSE maths and English for that matter. And in the UK, the law says that if you haven't achieved a grade 4 in maths and English, then you have to keep studying it until you either achieve it or you reach the age of 19. So I was teaching these rather reluctant 16, 17, 18-year-olds. I found that quite a challenge initially, but I also found it an eye-opener for me, and I found things about my teaching that I'd formerly taken for granted. I'm going to share some of those with you today. And I took them for granted, and I wish I hadn't really, but you're never too old to learn. So that's what I did for my teaching. In terms of Pearson, where do I fit in with Pearson? Well, I have been working for Pearson for most of my teaching career. I started off as an examiner, mainly for A-level, all the modules, but right at the moment, I'm chair of examiners for further pure maths international GCSE. That's 4 PM1. I'm chair of examiners on international primary. I'm chair of examiners on international lower secondary. And I'm also a principal examiner on A-level pure maths. I'll just explain very briefly what these roles are. The chair of the examiners is responsible for maintaining standards of the examination year on year. So that means that I have to scrutinize every part of the way the examination is written by authors or by the principal examiner. I have to supervise the marking of that exam to make sure that it's absolutely consistent series to series, year on year. So we're always marking in the same way, and we treat every candidate exactly the same way. The principal examiner is usually the person who writes the papers. I was principal examiner and chief examiner on further pure maths. Sorry, I'm not sure what happened there. Can you all mute your microphones, please? Thank you. I was principal examiner and then chief examiner on further pure maths for PM1 for a long time. But then I moved to be chair of examiners. So the principal examiner writes the paper and the principal examiner runs the paper. And the whole principle, the ethos that we have is that every candidate is treated exactly the same way, and that's the principal examiner's job, to make sure that every single candidate is treated exactly the same way. That's what I've done on examining. I'm also an author, and I was the series editor on the international A-level textbooks, the Pearson international A-level textbooks, all 14 of them. And the last thing that I do is I'm obviously carrying out, Pearson like to call me a trainer. I personally prefer to call these seminars. I'm sharing information with you, not really training you. This is a sharing of information. And today I'm going to share information about our two specifications, Spec A, Spec B, and so that you know what to do to start teaching it. I've travelled all over the world for Pearson. It's been a colossal privilege, all over the Indian subcontinent, all over Asia, China, and that has truly been a great privilege. Right, that's about me. That's my life story. It doesn't take very long. So, welcome to this professional development. So, this is designed and has been set up for teachers who are already teaching, or who are looking to teach the Pearson Edexcel International GCSE Math Specification. In this particular case today, we're looking at 4MA1 and 4MB1. I sometimes refer to them as Spec A for 4MA1 or Spec B for 4MB1. So in case I refer to either of them, you know what I'm talking about today. We're going to explore the content of the International GCSE Maths A and B. We're going to look at some examiner reports. In fact, when I've been all over the world, that's one question I ask delegates who attend the sessions, the seminars, say, who reads examiner reports? Very few hands go in the air, and sometimes none at all. I'm going to go through them. I'm going to show you how you can use them to your advantage. To look at planning a course of study using the resources on the Pearson website. We're going to look at how assessment objectives lead to the way examination questions are designed. We're going to see have a look at mark schemes. Now, mark schemes are another incredibly useful resource, and it's important as teachers that we know precisely how to use them, so that when we are marking our students' work, we can mark them to exam board standards. To learn how we use our sophisticated data gathering technology to reach a reliable reward. I have to say that the statistics that Pearson gather on the data they gather is actually mind-blowing, and it is incredibly sophisticated. And we're going to discuss best practice and share ideas today. So, welcome to Pearson. A little bit of marketing to start the session off. So, we are the world's leading learning company, and as the UK's largest awarding organisation, best placed to provide qualifications aligned to the British educational system. Our international heritage stretches back over 150 years. It was called London Examinations then. And it was called London Examinations up until even when I was doing my O-levels and A-levels, although in fact I didn't do London Examinations, but the exam board was called that at the time. Today, we partner with schools, universities, and employers worldwide, offering world-class, globally recognized qualifications to over 3.5 million students a year. The salient point that I want you to take away from this is that international GCSE, and for that matter, international A-level, although we're not talking about international A-level, is every bit as equivalent as home GCSE, home A-level, and is accepted throughout the world as direct equivalents to the UK home GCSE, UK home A-level. You can be absolutely assured of that colleges, universities, employers worldwide accept them in equal measure. In fact, a number of our prestigious private schools in the UK teach international GCSE. That's not because they think it's easy or anything like that. There's no such suggestion of that. It's just that a lot of UK private schools do have a lot of overseas students, and it suits them slightly better. And that's the only reason for that. International A-level is not available in the UK because international A-level remains modular, whereas in the UK, A-level is now linear. It reverted back to linear about 4 or 5 years ago. So international A-level, IAL, is not available in the UK, but the content is the same pretty much. There's minor variations, but overall, they are directly equivalent. Trusted and recognized qualification partner to 6,500 schools, colleges, and employers globally, and we mark over 10 million exam scripts on behalf of the UK Department of Education each year. So, as I say, you can be confident that our qualifications will be recognized throughout the world, and the rigor and demand of our international assessments is directly comparable with that of the UK qualifications. And in fact, most of the examiners on UK home and international qualifications are usually the same people. Okay, we offer a suite of 3. We offer a suite of 3 international GCSEs at international GCSEs. 4 MA1, that's specification A, and that's from grades 9 to 1. That is offered now both as a linear and as a modular specification. We also offer 4 MB1, and there's a slight typo here, so please forgive me. That is only offered from grades 9 to 4. And we call that Spec B. That's slightly different to 4MA1. You'll see why during the presentation. And the third one we offer, and there's still another typo here, Spec B and Further Pure Maths are both 9 to 4 only. 9 to 4 only. So 4 PM1, Further Pure Maths, and that's 9 to 4 only. We are not going to be talking about Further Pure Maths today. That is tantamount to an A-level, really. And as I said, 4MA1 is offered both as a linear course, and as from the first sitting was in June this year, just gone, it's modular as well, and that's consisting of 2 units. I will just mention that on higher Spec A, higher Spec B, and indeed on 4PM1, Further Pure, we do award a grade 3 as a safety net, is probably the best way to describe it. It's just a safety net. there are no grade 3 questions on the higher for MA1. There's no grade 3 questions on for MB1, and there's no grade 3 questions on further pure maths. Okay. I'm now going to talk about international modular GCSE. So it's not really an announcement because the first examinations have taken place, and indeed teaching started in September 2024. The content of the specification is exactly the same as the linear specification. It is exactly the same. Content is identical, and indeed the assessment objectives are also identical. So the exam and the spec say exactly the same. Now, there is a decision to be made whether you want to teach the linear course or the modular course, or perhaps even both in your schools. It won't. This is my personal opinion. I think that the modular course will suit many students very well, but I think in some respects the linear course may suit other students slightly better. Particularly, and again, this is just my opinion, particularly for very, very able students, I have a feeling that they would prefer to do the linear course where they do one exam, basically paper 1, and a week later they do paper 2 and just get it over and done with. But as I say, that's just my opinion. So these two routes of assessment. If you're happy with the linear approach, there's no pressure to move to the modular route. Our linear GCSEs will be continued to be offered and will be taken widely by students around the world. I do know, as I've had the pleasure and the privilege of basically going around the world, that the modular course is going to be very popular. The modular route. Unit assessments could be taken over multiple exam series. And the grades are calculated as raw scores, which are then converted to a UMS, a uniform mark scale, exactly the same as in A-level. So the papers, Unit 1 and Unit 2, are both have 100 marks in them, but the UMS score for modular is 120. So the raw score, whatever a student gets, is converted to a UMS score, and then that UMS score is carried forward. It has to be that way, because otherwise, if a student resits Unit 1, it has to be comparable to a previous examination. Once a student, so students can resit individual units. There are exceptions to that. I'll talk about that just a little in just a little bit. Once a student has all their unit results, they can cash in these results for their grade. Exactly the same as A-level. That's the modular route. And on the linear route, assessments for all units are taken together in one exam series. The grades are calculated purely on raw marks only. We do something called an awarding meeting, where we look at data, we look at previous series, we compare the exam that we're going to award with papers from previous series to make an assessment, make a judgment on whether it's slightly more difficult or it's slightly easier. And we take all of that into consideration, plus the data, with a very professional discussion, and then that's how we decide on grades. Students can resit assessments for all units together in one exam series. So if a student wants to resit linear GCSE, they have to resit paper 1 and paper 2. And then at the end of that exam series, the grade the students get is given to them in the exam series in which they sat their assessments. A modular route is only offered by Pearson Edexcel at international GCSE level. We are the only awarding body that offers modular GCSE. So let's have a look at a little bit more detail. Right. So the modular exam structure. Unit 1 and Unit 2 is offered in Foundation from grades 5 to 1, and it's offered in higher tier, grades 9 to 4. Each exam is 2 hours long. The total number of marks is 100. The weighting is 50%. So in other words, Unit 1 is half of the award. Unit 2 is the other half of the award. And the grade range for Foundation is 5 to 1. The grade range for a higher tier is 9 to 4. Now, this is quite important. There are 5 grades at Foundation: 1, 2, 3, 4, 5. And 20 marks plus or minus 1 mark is allocated to each grade. So if you want to know where the grade 5 questions are, they're the last 20 marks on the paper. I'm not going to sit here and try to convince you that grading a question is an exact science, because it's not, but it's based on a huge amount of experience, on a huge amount of scrutiny by very, very experienced examiners who make a judgment. Now, the grade range on higher is 9 to 4, and that's 6 grades. Grades 4 and 5 questions on the higher tier and the Foundation tier are identical. I mean, it actually says approximately 40% of the questions. Not strictly to it, it's actually exactly 40% of the questions. So, on the higher tier paper, the first 20 marks are grade 4 questions. The next 20 marks are grade 5 questions, which are the same as the grade 4 and 5 question on Foundation. And then we've got grades 6, 7, 8, 9. That's 4 grades. We've got 60 marks, so there's 15 marks at grade 6, 15 at 7, 15, 8, and 15, 9. That means that if you want to know where the grade 9 questions are, they're at the end of the paper, and it's the last 15 marks. Both for MA1, whether it's linear, whether it's modular, the papers are ramped in difficulty. Strictly ramped in difficulty. So the demanding questions, most demanding questions are at the end, the least demanding questions are at the beginning. For each unit exam, a formula sheet is going to be included. That's on page 2 of the booklet, and calculators are allowed to be used. I often get asked, well, what sort of calculators can students use? Well, I'm just looking on my desk. I've got a Casio ClassWiz, which is a very advanced calculator. They can use that. Students can use a graphic calculator. Graphic calculators tend to be more complicated to use. They're allowed to use them at A level at school. Certainly, we used to loan graphic calculators to our sixth formers, so they could have a graphic calculator in the exam and an ordinary calculator. that was particularly useful because I used to tell them to keep the graphic calculator in radians and keep the little calculator in degrees, which is so they wouldn't have to keep swapping and then getting some very silly numbers in any question that required work with angles and trigonometry. Okay. Here's the modular content summary. Assessment objective 1 is number and algebra. Okay, so that's the unit 1 and unit 2 content. So the modular and linear approach, they have exactly the same content. But the modular approach breaks the journey into 2 units with an exam at the end of each unit. So I'm not going to read all that out for you. Clearly, the foundation topics are in black. The higher topics are in red. However, I cannot stress this too strongly. Higher tier candidates are expected to know the entire foundation content. Okay, they're expected to know foundation tier, foundation content. So, so it's not a case of unit 1 is just going to have surds and indices. Unit 1 will have, on the higher paper, basic number skills, standard form, limits of accuracy, and surds and indices. In terms of algebra, Unit 1 will have all those basic algebra, set notation, etc., and solving quadratics, completing the square, the quadratic formula. It is crucial that you understand that higher tier candidates are expected to know the foundation tier content in full. Now, we're not going to ask a question on higher. We're going to give a list of numbers and ask students to identify the even number, the odd number, factors, and multiples. But we could certainly ask a question on the higher tier paper. For example, show that the sum of squares of 2 consecutive odd numbers is always even. So that's got even numbers, odd numbers. Clearly, a question like that is a grade 9 question, grade 8, 9 question. And it's obviously way beyond what we'd expect competence at foundation, but it's using the words even and odd. So I'm just stressing that, how important that is. Okay, whatever we test in Unit 1 will not be retested in Unit 2. That's one advantage of modular, in that you know basically what's coming up. AO2 is space, shape, and measure. Assessment objective 2. And assessment objective 3 is handling data and basic probability. Exactly the same applies. Higher tier has to know everything that's on there. Foundation is what's in, looks like blue only. So I'm just going to stop there for a minute or so and just let you have a look at that. Okay. Right. Well, clearly, if you're going to be teaching modular, and I suspect a lot of centres are going to be doing some of both, some linear and some modular, depending on their students. So you may want to adjust the way you teach International GCSE Maths A specification if you want to take the modular route. Now, to support your planning and teaching of the course, we have course planners, editable schemes of work, which are published in Word, which means that you can copy and paste them, and we have a document called a Getting Started Guide. Now, the Getting Started Guide is a particularly useful document because that I really encourage you to read and have a look, because it'll have exemplars, it'll have student responses, so it's going to have a lot of information in there. The first teaching, obviously, was a year ago in September 2024. That's when we started, and the first assessments took place just now in May and June of 2025. I do encourage you to make use of the resources that we have. At college, where I worked, the policy of the college was that we had to use the pro formas of the college. So that's, all their forms, all their paperwork, and we had to update our schemes of work or have a look at them all the time. Now, when I got there, when I got to college, because I didn't realise it, I told them that because the schemes of work are editable, and we could just copy and paste. So all we did, we just copied and pasted the scheme of work for GCSE maths, put it into the college paperwork, and we had a scheme of work. There it was. Everything was there, everything what we needed, and it was very, very quick. Right. Resit. Resits. Students can resit any unit irrespective of whether the qualification is to be cashed in. If a learner, now this is an important rule, if a learner resits a unit more than once, only the better of the two most recent attempts of that unit will be available for aggregation to a qualification grade. What this means is that if a student resits a unit 3 times, and the first time was their highest scoring attempt, that result will be lost. So it's only the better of the 2 most recent attempts. We will hold results of units in the unit data bank for as many years as the specification remains available, and because it's new, then it's likely to be for some time. And once international GCSE has been certificated, all unit results will be used up at that level, and those results can't be used again towards a further award. Once they're cashed in, they're cashed in, and that's it. Okay, specification. In the specification consists of 2 things. The specification, in other words, the content, that which what needs to be taught, that which has to be learned, and the means by which we test what our students who follow our courses can do, and we call those assessment objectives, and those are the examination papers and the associated mark schemes. Now, the key word in our assessment objectives is students should demonstrate. And that is a reflection of real life, is it not? Because if a student is, if an employee is employed to do something, and they have to employ calculations, they have to surely be able to demonstrate where they got them from. So, for example, just anecdotally, my youngest son, he's a civil engineer. He works on the high-speed rail project in the UK. And when he does calculations, he works quite a lot with concrete at the moment. He has to support his calculations with where he got them from. And it's no different here. Students have to know the content, and then they have to demonstrate what they have learned by what we call the assessment objectives. Now, the specification is the main document you need to teach the course. There's a picture of it, the front cover. It outlines the aims of the course, the content you must cover, and all the information you need about assessing your students. It also contains all the information your examination officer requires to run the specification, what to do, and it has all the information about the reason behind the specification. And a copy of this document is on your online pack, and it's on our website. Every single teacher should have access to the specification, especially those pages in the middle. I think it starts at page 21 where the content starts, and you should be referring to that the whole time. Now, that was a mistake that I made when I very first started teaching. I was given some textbooks and told to teach to them. That's not right. You teach to the specification. It is far, far too easy to teach the wrong material. It happened in my school, not in maths, I hasten to add, but another subject, where some students walked into an A-level exam and they got the shock of their lives because the spec had changed. There was quite a furore about that, not too surprisingly. It is very easy not to teach sometimes the wrong things and not to teach to sufficient detail. I cannot stress how important it is that every single teacher has a copy of the spec, either at their side, if they're old-fashioned like me, they'll have it in a paper version, so I can write all my little notes, scribble my little addendums and all my little notes into it, or they have it online. It's absolutely crucial. The starting point for teaching is the specification, not the textbook, not even if it's written by Pearson, and not even if it's written by me. So that is your starting point. The second crucial thing, sample assessment materials, we call them SAMs. And that document is just as important. And every teacher should have a copy also of the SAMs. So the SAMs are examples of the question papers and mark schemes. It shows the question types. It'll have the language of the exam, the style of questions, the mark distribution, the type of questions, and this document is something else that should be frequently referred to by teachers. Now, it says here we base all of our future papers and assessments on the sample assessment materials. It goes a bit further than that, actually. When we're signing off a paper, so if I write a paper, it goes through 8 stages of scrutiny, which takes, so papers are written something like 2 years in advance. It takes about a year for a paper to get from writing to being basically in the bank, ready to be printed, finally to be sent out to centres. It takes about a year for that process to happen. And we have to sign a declaration that the paper that we have written, the paper that we are signing off, conforms to the pre-release materials. So in other words, the sample assessment materials. It is crucial that you have that document as well. You must have. There are other documents which are really useful, and I'll refer to those later. There's pictures of them in the presentation, but those two are basically non-negotiable. Every teacher should have those at their side. Very easy to make even small mistakes. Give you an example of that. At college, we used to, I didn't particularly agree with it, but I mean, the powers to be decided that they wanted a baseline assessment. So the first lesson, as soon as our new students walked in September, the first lesson they'd have to do a test. It was a past paper, and one of the questions had a grid. It had 2 lines drawn on it, and the question, and then underneath the question said, line L, the equation of line L is this, the equation of line K is this, solve the simultaneous equations for 2 marks. It says clearly on the specification that students need to be able to solve simultaneous equations by recognizing that the solution of simultaneous equations is the intersection of 2 straight lines. Very few students were able to answer that question because they just didn't know. They didn't know that all they had to do is to pinpoint where the 2 lines cross and write it down, the coordinates. That's all it was. Seriously, that's all it was. And things like that, small details, very easy to miss out. Right, so a little bit more detail. So for MA1, foundation and higher tier. So it's arranged as 6 broad topics, arranged into subtopics, and as a minimum, all the content must be taught in each tier. Let me remind you again that the higher tier spec relies on the whole of the foundation spec being known. Now, foundation tier covers grades 1 to 5, higher tier grade covers grades 4 to 5, where the grade 4 and 5 questions are common. So what have we got here? Sequences, functions, and graphs. Understand, so students should be taught too. I used to use these as my lesson objectives. It was as simple as that. It was that easy. Understand and use common difference, D, and first term, N, A in an arithmetic sequence. Know and use the nth term. A is equal to N minus 1, D. Find the sum of the first n terms of an arithmetic series. Well, clearly, this is higher tier content because arithmetic series came down from A level in the when the spec was rewritten in 2017. We've also got explanatory notes. For example, given the second term is 7 and the 5th term is 19, find A and D. If the word is used in the spec, we can use that word in the examination. It's very important. So, what I found at college, this is something that I learned about myself, and I have no hesitation in admitting it, was that the students at college, a lot of them didn't understand command words. Now, the command words are in the sample assessment materials. Command words like simplify, factorize, expand, expand and simplify, solve, the difference between an expression and an equation. Most students really didn't have a clue. And because they didn't have a clue, if they don't understand the word, the command word, they certainly can't answer the question. For example, simplify a fraction in simplest terms. Or write this fraction in simplest terms. That is in the specification in Foundation. If they don't understand what simplest terms means, they won't be able to do it. Even if they know the principle of what that is, they know how to do it, but if they don't understand the terminology, they will not be able to understand what to do. So if the word is in the spec, we can use it in the exam. Now, the modular scheme has got exactly the same spec, but it's split between the two units. Right. Let's have a look at MB1. MB1 is only available in higher tier. And this is also really important in the rubric. In the specification, it says there quite clearly that for MB1, the content in 4MB1 relies on knowledge of 4MA1. It says that in the specification. It's in the rubric at the front. So it is assumed that if something is in 4MA1, an extension of that can be tested in Spec B. Now, Spec B is very, very popular in Bangladesh, in Pakistan. The Indian subcontinent really, really likes Spec B. And it is indeed a lovely exam. It's got some lovely mathematics in there. Now, Spec B is arranged in 10 broad topics, and all the content must be taught. And it's exactly the same, what students need to learn. So in matrices, representation of data by matrix, addition and multiplication of matrices, etc., etc. Now, matrices, of course, is a further pure one maths topic. And we've got up to transformations in matrices on Spec B. So that is a different exam, but 4MB1 relies on what is known in 4MA1. Right, assessment. We write examinations, or we construct exams to a very, very strict set of rules by a senior team of experienced examiners. The people who write the papers that your students will see are very, very experienced examiners. They've been examining for a very long time. They've been working as team leaders, and the scrutiny that is placed on writing an exam paper is very, very intense. Don't have time to go through it. Now, there are 8 stages of scrutiny, and we check and check and check. So we look at content. In each assessment, whether it's Spec A, Spec B, or indeed an A-level paper or further pure maths, we try to cover as much of the content as possible. Now, in the case of modular, so across the 2 units in modular, you're going to know what's coming up in each unit. On the linear route, we will attempt to cover as much of the content as we possibly can across the 2 papers. The assessment objectives, as you'll see in a moment, the assessment objectives do not change. So there's always going to be a certain number of marks, which is 60, plus or minus 3 marks for number and algebra, 25 marks for space, shape and measure, 15 marks for data handling and probability. Within those assessment objectives, questions will be problem solving or mathematical communication stroke reasoning. We always write the mark scheme at the same time as we write a question. So if I write a paper, if I write question 1, question 1 is complete when the question is written and the mark scheme is written. And we make sure that we award marks for each stage of mathematical, each step of mathematical work that is carried out. And we consider grading procedures in terms of the fact that certainly for MA1, foundation and higher, 20 marks plus or minus 1 are grade on the foundation of grade 1, the next 20 are grade 2, the next 20 are grade 3, etc., etc. Okay, so let's have a look at these assessment objectives in more detail. Doesn't matter whether it's linear or modular, these assessment objectives are exactly the same. AO1, assessment objective 1. Demonstrate knowledge of facts, techniques, and relationships in numbers and the number system, equations, formulae, and identities, sequences, functions, and graphs. So essentially, AO1 is number and algebra. 60 marks on each paper are going to be on number and algebra. It doesn't matter whether it's foundation, whether it's higher, whether it's modular, or whether it's linear. On each paper, 60 marks will be on number and algebra. AO2. Demonstrate knowledge of facts, techniques, and relationships. It's that word demonstrate again. In geometry, and then vectors and transformation geometry. There are no vectors in foundation tier for MA1. So on foundation, we've just got geometry and transformation geometry, and that includes trigonometry. But there's no vectors on foundation. And there's 25 marks plus or minus 3 marks. Every single paper, whether it's modular or linear, foundation or higher, will contain 25 marks plus or minus 3 on AO2. And AO3, statistics and probability, it's 15 marks plus or minus 3. Now, they might seem as fairly generous, those tolerances, but it's not too difficult to work out that if you use the full number of marks up, 63 marks on AO1 and 28 on AO2, well, that's 91. So you're only left with 9 marks left for data handling and probability, and that won't do at all. So in reality, it's much closer than that. Do not forget that some questions can have both AO1 and AO2. So you could have a geometrical diagram with some algebra in it. So it will have a mixture of AO1 and AO2. Or you could have a problem-solving question. You could have a picture of a floor. And candidates are asked to calculate the cost of painting the floor. Something like that. So that would again be a mixture of AO1, AO2. This is important because it could be an indication to you as teachers, as teaching professionals, whether the foundation course or the higher course is more appropriate for foundation, or a student is better suited to foundation or higher. So in AO1, the split of number to algebra, or the ratio of number to algebra, is 3:2, which means that 36 marks are going to be on number and 24 are going to be on algebra. Whereas the other way around, on the higher paper, the ratio of number to algebra is 1:2. So that 20 marks are going to be on number, 40 marks are going to be on algebra. The reason for that is the greater emphasis on algebra is to prepare candidates for progression to A-level. Now, you don't need me to tell you the students find the jump between GCSE and A-level quite difficult. Not all of them, but some do. The problem is, of course, that they find the algebra difficult, because all of a sudden they have to do perhaps statistics or mechanics, and everything's algebraic. So I have found really good candidates got a grade A when I was still teaching GCSE at school. Got a grade A. Can I do A-level, sir? Yeah, brilliant. Go to A-level and they really struggle. I've also had candidates who have got a grade 6. I mean, it was a grade B at the time, and they actually thrived on it. They did well. So some students do find the transition between GCSE and A-level difficult. You know that as well as I do, exactly the same. And the emphasis on algebra is to prepare students for A-level. Right. So the structure of 4 MA1 papers, 1H and 2H. Assesses all the content in the specification. All the content means foundation and higher. Questions can come from any topic area from the assessment objectives. And that includes, as I've just mentioned, questions that address more than one topic. Each paper is assessed through a 2-hour examination set and marked by Edexcel. Kind of goes without saying. 50% of the qualification, they're equally weighted. Whether it's modular unit 1 and unit 2, it's half of the exam. Whether it's paper 1 and paper 2, it's half of the exam. It targets grades 4 to 9. We do allow a grade 3 safety net, but that is only a safety net. There are no grade 3 questions on a higher paper. Has around 20 to 25 questions with varying mark allocations. The mark allocations for each question, each part of a question, is stated at the side of the question. It is really important that you teach your students to look at that, so that they look. So if it's got 1 mark there, you're not expecting a lot of work. It could be a write down. Yeah, or a very simple thing. If it's got 5 marks there, then a substantial amount of work is required, and a single line isn't going to do it. Each paper has a total number of 100 marks, and each paper you are allowed to use a calculator, and the papers, once again, are ramped in difficulty. So I've already mentioned this. Just go through this slide very briefly. 40% of the marks are distributed evenly over grades 4 and 5, because the questions are the same as the grade 4 and 5 questions on foundation. And then 60% of the marks are distributed evenly over grades 6 to 9, which means that there are 15 marks for each. And foundation tier, all marks distributed evenly over grades 1 to 5. And the tolerance is 20 marks plus or minus 1. As I said earlier, grading a question is not an exact science. I'm not going to pretend that it is, but it is based on the enormous collective experience from some very, very senior people. So here's an example of a grade 4-5 question. As it happens, this is also a problem-solving question. I'll show you the criteria for a problem-solving question in a later slide. And this question was both on foundation and higher tier. We always give an instruction on the right-hand side, diagram not accurately drawn. Make no mistake, how many students will attempt to scale it and measure it. Let me read it. A diagram shows a roof support. The roof support is made from 4 lengths of wood: AB, AC, BC, and MC. AC and BC is 9 meters, AB is 12 meters, and angle AMC is 90 degrees, which is marked on the diagram. Lewis is going to buy lengths of wood to make the roof support. The wood costs 21.5 euros per meter. Each length of wood he buys has to be a whole number of meters. Work out the total cost of the wood Lewis needs to buy. Show you're working clearly. So I've completed the first step in answering this question. I've read it all the way through. The information in the question is given in the order in which it needs to be answered each and every time. So we've got information. We know what AC and BC is, and we know what AB is. What we don't know is what AC is. Sorry, CM is, MC is, which means that we're going to have to use some maths to find what CM is. So the solution to this question is not directly obtainable. It doesn't have instructions. It doesn't say find CM. So a student has to work that out for himself. That is one of the criteria that makes it a problem-solving question. So the information is given in the order in which it needs to be used. Here is a grade 8 question. Now this is not problem-solving because it's a standard procedure to solve this. Students don't need to know what the curve is. It's an ellipse, actually, obviously. And there is an instruction to show clear algebraic working. And the reason for that is that a savvy student could actually do this on a graphic calculator. I've got an ancient TI-83. Probably needs to go into an antiques fair now, but I still use it, and I still find it extremely useful. I'm sure there's far more efficient and modern machines available. but I could quite easily do this on my TI-83 and solve it that way. That is why it's got show clear algebraic working. We write instructions like that. I'm sorry about my cough. We write instructions like that if a question could be solved using a calculator. And that is a grade 8 question. And this question, you know as well as I do, you could actually find it on a P1 paper on international A level. So there is the overlap between GCSE and international GCSE. Right. Let's have a look at 4MB1. Now, 4MB1, the assessment objectives are exactly the same. AO1, assessment objective 1, number and algebra, 60 marks plus or minus 3. AO2, space, shape and measure, geometry, vectors and transformations, 25 marks. And AO3, statistics and probability, 15 marks plus or minus 3. It's exactly the same as Spec A for MA1. So on paper 1, it's actually got 28.5 to 31.5. That is of the overall award. But on paper 1, 60 marks plus or minus 3 are going to be on number and algebra. 25 marks plus or minus 3 are going to be on space, shape and measure. And 15 marks plus or minus 3 are going to be on data handling probability. Exactly the same for paper 2, even though paper 1 and paper 2 are very, very different. Now, on Spec B, the papers are not strictly ramped. So it is absolutely not the case. If you want to know whether grade 5 questions are, grade 4 questions are, it's not necessarily the case that you'll find them at the beginning of the paper. I have to say that on any paper, whether it's A-level, further pure maths, Spec B, all the papers will start off with an easy question. It would be a very poor author who would put a very difficult question right at the beginning. We want to settle our students, our candidates into the paper. We want them to be comfortable, settle into the paper. Nobody is trying to trick anybody. Paper 1 on Spec B and paper 2 are very different. So, some of all the content is going to be assessed on paper 1. In the ratio I've just said, 60, 25, 15. Number and algebra, space, shape and measure, and data handling. And questions can come from any topic area, and could be questions on, questions that cross 2 content areas. Paper 1 is a 1 hour, 30-minute examination. And it is weighted at 1/3 of the qualification. Its target grades 4 to 9 with a grade 3 safety net, and has about 40%, and this is about 40%, of the paper distributed evenly over grades 4 and 5, and 60% distributed evenly over grades 6 to 9. And it consists of 26 to 30 questions with varying mark allocations. Now, on Spec B, the short questions are at the beginning, the longer questions that are at the end. And Spec B will start off with 2 mark questions. Then it'll go to 3 mark questions, 4 mark questions, 5, 6, and then a couple at the end, maybe up to about 7 marks. But the short questions are at the beginning. So if there was a grade 9 question with only 4 marks, that would be around the middle of the paper, which is why I've just told you that Spec B is not strictly ramped in detail. A calculator is allowed. Paper 1 is 1/3 of the total spec. Paper 2 is a 2.5-hour examination, and that is weighted at 2/3 of the qualification. Once again, targets grades 4 to 9, has approximately 40% of the paper distributed evenly over grades 4 and 5, and then 60% distributed evenly over grades 6 to 9. Now, paper 2 has about 11 to 12 questions with varying mark allocations. Once again, those mark allocations are stated. Some questions on Spec B will be up to 16 marks, 17 marks. They'll have parts A, B, C, D, E, F. I have written Spec B papers. So, for example, one question I wrote a long time ago, which I think it was sat in 2017 or 18, pretty sure. It would have been around then, about 2017. I wrote a question on matrices and transformations. So it starts, so not only it was a 16 or 17 mark question, but the question itself was also ramped in difficulty. So part A was the easiest part of the question. Then part B was a little bit harder. Then part C introduced, so that had some work on transformations, enlargements. And then part C, D, that's when I introduced matrices into it. And there was a transformation involving matrices. So it has highly developed questions, and once again, a good question, a good developed question is a question that starts easily. We would never put the hardest part of the question to start. I mean, it'd be ridiculous, because a candidate may not be, if they can't do that, then they can't do anything. We give a candidate an opportunity to show us what they can do working through the question. So here's an example of a grade 5, 6 question, probably on paper 1. Right, 0.000,01596 in standard form. Very easy. The star Sirius is approximately 81. I'm not going to say that, I find it too difficult. From Earth, light from Sirius takes approximately 3,142.7 days to reach Earth. Calculate the speed in kilometers per second to one significant figure that light travels from Sirius to Earth. Give your answer in standard form. Show you're working clearly. Although it says show you're working clearly, students should be taught. I always, at school, it was easy. They were far more inclined to do what I asked them. At college, we only had them for 1 year. We had them for 32 weeks of the year. These are students who came from various schools throughout the district. And some of them just, I used to say to them, how do you tell an examiner what's in your head? You write it down. Show you're working each and every time. Don't just try to do it in your head. It isn't possible. Now let's have a look at this. 1 mark, it says 1 here. It's telling candidates 1 mark. There's only 1 mark for it. It's either right or it's wrong. So all they have to do is just write it down. And then 4 marks. 4 marks is saying there is going to be a lot of work to do. It's going to be a lot of calculation to do for those 4 marks. So that there is an indication of what a student has to do for those 4 there. 4 marks means a lot of work. That's what they have to do. Right, let's have a look at a grade 7-8 question. Question on functions. So we're given candidates are given a function. H of x is 2x squared plus 4x minus 5. Now that could be written. Now the function notation will be in more than one form, and students have to be familiar with all of them. Express h of x in the form a x plus b all squared minus c. So in other words, they have to complete the square where a, b, and c are integers. 3 marks. Part F. Hence, find the inverse function h to the minus 1 in the form h to the minus 1 of x for 2 marks. Hence is a tricky word. Because it says hence, it doesn't actually say hence or otherwise. It says hence. Hence means that they should be using, they have to use their result from E. Now you notice that this is part E and part F. This is clearly a paper 2 question because there's going to be parts A, B, and C. They're going to be worth some marks. So the total marks for this question is certainly going to exceed 10 marks. So this will be a paper 2 question. A long developed question on functions on algebra. Okay, so in summary, for MA1, short answer questions. The extended response questions on Spec A will have a maximum generally of about 6 marks. They will contain problem solving and reasoning. Spec B, short answer questions are in paper 1, those between 2 marks and 7 marks. And in paper 2, we'll have extended response questions, which generally have between 10 to 16 marks, and those are in paper 2. They will have problem solving and reasoning questions. In fact, quite a large proportion of each of these papers is problem solving and reasoning. Right, so we've got activity 1. Now, you should have downloaded the delegate booklet. And the delegate booklet has got 2 questions, the questions we looked at earlier. So, have a look through. You don't have to do the question. I'm not expecting you to do it. I know you can do it. But as it happens, I did it, but that's by the by. You have the mark scheme for question for the grade 8 question. So have a look for what skills are being assessed. I haven't actually talked about problem solving yet, but just have a think about it. Do you think that they constitute problem solving? And is the grade 8 grade question for MA1? Do you think that's a good preparation for A level? So I'm just going to give you. I'm not going to give you long because I think we're probably running behind slightly, and we're going to have a break in about 10 minutes. So I'm just going to give you 3 minutes just to have a look at that.
Hello. Just
Hello?
noting it. Hello. Nobody's got the booklet.
Have you not? You should have downloaded. They should have been downloaded. Okay.
Yeah,
Well,
but there's loads of people saying I
I
haven't
know.
got it and I haven't got it.
Yeah. I'm just flicking through the. I'm
Yeah,
just
look, we
flicking
haven't got
through
it
the.
basically. Thank you.
Yeah. You haven't got
I'll
the
I'll turn my
booklets, right?
microphone off.
Okay. So we're going to do this a slightly different way then. So I'm going to stop sharing this, and I'm going to share. Have I got that? Oh no, hang on a minute. Share. I'm sharing the wrong thing. Oh, here we are. Delegate booklet. Share. Right. Okay. Thank you very. Right. Well, that's the wrong booklet. Right. Stop. So save me making a mess of this. I can't understand why I've got that. Oh my goodness me. Share. Right. Okay. Right. I can't even remember where I was. Well, I can remember where I was. I'll find it in a second. Right, that was activity one. Okay. Right. Well, I'm going to try. I'll try and sort that out during the break. But in the meantime, let's go to this from current slide. That's activity one. I'm going to try and sort out. Hansel, are you there? I'm not sure he's able to answer me, but Hansel, can you just have a look to see if everybody has the delegate booklets, please? And if they haven't got them, can you email it to everybody, please? When we stop for break in about 5 or 6 minutes. Right. Okay. Well, I will go through this one anyway. So, this is the first question that I asked you to have a look at. Right. There is an element of problem solving here, obviously not in part A, which is 1 point, it was just straight, it's just a straight right down, 1.596 times 10 to the minus 5. That's it. It's either right or it's wrong. And this is a question that will be actually clerically marked. So questions on spec A and spec B, some questions will be marked by clerical markers, some will be marked by graduate markers, but the majority of questions are marked by expert markers. And a clerically marked question is a question that is either right or it's wrong. It's as simple as that. So there's no room for any judgment here. There is no judgment to make. The answer is 1.596 times 10 to the minus 5. If that isn't there, it does not score the mark. Now, on part B, so we're given information in the stem of the question. The star Sirius is approximately that. And then we need the problem solving element is that students will need to convert by realizing that the speed required is in kilometers per second. They have to change the days into seconds. And they also need to use speed is equal to distance divided by time. So the time is obviously 3142.7 times 24 times 60 times 60 to change it into seconds, and then use speed as distance over time. Now, on the second question, which you haven't got, which was the algebra one, which is the algebra question, that is, so actually I will find it again. Let me just find that question very quickly. It wasn't there, was it? No. So it was that question. It was asking, the activity was to have a look at that question. Right. So It's a standard procedure, this. What we have to do, it is reasoning, it's mathematical reasoning, because mathematical reasoning is defined as performing algebraic manipulations. But a candidate has to either say x is equal to 5 minus y, or y is equal to 5 minus x, square it and substitute it into the equation of the curve. It is a standard procedure. And what we do then is that we solve for x, we find two values for x, and then we substitute back and find the two corresponding values for y. Now, because it asks for the coordinates of the points, the values of x and y must be paired. We would accept, if a candidate wrote, when x is, as it happens, when x is 9, y is equal to -4, and when x is -3, x is equal to 8. We would award the marks for that if a candidate did not give us coordinates, but the values would have to be paired. Okay, so let me just move forward again. As I say, we're going to stop in a minute. Mathematical skills. Actually, I think this is probably quite a good time to stop. So on my phone, it should be 10:28 UK time, 10:28. So I would like that now to resume in 12 minutes, and I'm going to restart at 10:40, please. So we're just going to have a 12-minute comfort break, and I'm going to resume at 10:40 exactly. Okay, so I'm just going to mute myself. In the meantime, Okay, I've just been talking into a muted microphone, but we get there in the end. Okay, well, welcome back. So, mathematical skills for MA1. So, as well as testing knowledge of the content, that's AO1, a number and algebra, space, shape and measure, statistics and data handling, candidates are going to be assessed on their ability to solve problems in both a mathematical setting and in a practical setting. We call that problem solving. And then show reasoning, interpreting, and communication skills, and we call that mathematical reasoning. Right, well, here are the criteria for what makes a mathematical problem-solving question. Any one of these criteria, any one, makes it a problem-solving question. Just one. But quite frequently, they've got more than just one. So it could require use of techniques from more than one content area. So if a question has got geometry and algebra, it's automatically problem-solving. Requires a succession of processes, but not just the standard set as with the simultaneous equations. And we saw the simultaneous equations earlier on, didn't we? X plus y is 5, and 2x squared plus 3y squared is, I think it was 210. That is a standard set of processes. Now, that question is going to be mathematical reasoning, but it's definitely not problem solving. Is unfamiliar, so there's no obvious standard method of solution. Is in an unfamiliar context. So that question involving standard form with defining the speed in kilometers per second, it's not obvious. Students have to work out. They've got to work out that they need to change days into seconds and they need to use speed as distance over time. And requires translation to a form which allows suitable mathematical processes to be used to solve the problem. So, any one of those 5 criteria make it a problem-solving question. Frequently, a lot of problem-solving questions, there's more than one of those involved. Mathematical reasoning. Make deductions. Draw conclusions. Present arguments and proofs. Anything with a proof is mathematical reasoning. Show that the sum of 2 consecutive odd numbers is always even. So 2n plus 1 plus 2n plus 3 is 4n plus 4, which is 2 bracket 2n plus 2. You multiply anything multiplied by 2 is an even number, therefore it's even. That is a very, very simple proof. Interpret information accurately, communicate results clearly, and this could surprise you. So, for example, on a foundation question, 2 or 3, right at the beginning, grade 1, candidates could be given some information. They're given some squared paper and asked to draw a suitable diagram. They're not given the diagram to draw, they're asked to choose to draw a suitable diagram. So that's communicating results clearly. Here's a problem-solving question. 450 students were asked how they travelled to school on Monday. Each student walked, or travelled by bus, or travelled by bicycle. Old-fashioned, that bicycle now, I think. Each student used just one method of travel. One of these students is chosen at random. The table shows information about the probability of each method of travel. Work out how many of the 450 students travelled by car. Now, once again, The information is given, in which the order in which you need to use it. So the first 5 lines are setting the scene. So now what a student has to work out, or has to realize, that sum of probabilities is always going to be unity or 1. So that 0.2 plus x plus 2x plus 0.2x6 is equal to 1. That's not obvious from there. And the second thing is that it's not obvious that they have to solve an equation for x. So they have to find out what x is by solving it. As it happens, it's 0.18. And then they need to use that information. So then they need to double that and multiply it by 450. Because if we think about the criteria, there is no obvious method of solution, then that is what makes it a problem-solving question. But note that the information is given in the order in which it needs to be used. Here's another question. In the diagram, ABC is a regular pentagon. Angle AEF is 96 degrees. Work out the size of the obtuse angle FED. Show you're working clearly. And that would be a mathematical reasoning question. If we look back at the criteria, interpret information accurately, communicate results clearly. So that is a reasoning question. Geometrical proof, algebraic proof, invariably makes it a reasoning question. There isn't a proof here, but we want to see they have to show a clear succession of mathematical reasoning, a mathematical journey to find that angle. Right. Now, has anybody got, if I could, the lady that spoke to me earlier, Colleen, could you tell me, please, do you have access to the delegate booklet? Could anybody tell me? You do now.
I think
right.
It's the secret is to hit more at the bottom of the screen with the little dots.
Oh, right.
And then you'll see resources.
Okay. Right.
And
so hopefully everybody can have a quick look at this. I'm just going to give a couple of minutes because rather foolishly I've just talked through the question. So I'm just going to have just ask you to have a quick look at this, please. We'll go through the questions in a second. Okay, I'm going to just go through it because it is actually 10 to 12, so there's a fair bit to do here. Right, so I think a lot of candidates would know that they have to find the value of x, but I think the problem is I think that they may find that they may not know where to go from there. So the plan for this is use the fact that some of the probability is 1 to find x, and then we need to find 2x, double the value of x, and then multiply that by 450. This one, the second one, work out the interior angle. Well, that's obviously it's a pentagon, so it's going to be 108. Add it to 96, and then subtract it from 360. Can I just give one little piece of advice here, please, from my experience both as examiner and as a teacher? If students are asked to give a reason in geometry, the reason has to be complete. So if they're working with a question in a triangle, it's a foundation question, and they have to find an angle given 2 angles in a triangle. So very basic grade 2 foundation question. Give a reason for your answer. Some students, quite a lot of students, write a triangle is 180 degrees. And that's when I feel quite bad for students because I know what they mean. However, they would not score a mark for that because the reason is incomplete. The sum of angles in a triangle is 180. Angles in a triangle add up to 180. It's the same as angles on a straight line are not 180 degrees. Triangles on a straight line add up to 180 degrees. Angles around a point sum to 360 degrees. The reason has to be complete. Alternate angles on its own will not score a mark. Alternate angles are equal. So in this particular case, the internal angle is 108 plus 96. Take it away from 360 and I think it's 156. You could use the external angle, which is 72, which forms a straight line. So the whole angle would still come to, so the missing angle would then be 84 plus 72, which is still 156. So there's 2 ways of doing this. Right. On the foundation paper, out of the 100 marks on each paper, 25 marks are going to be problem solving and 15 marks are going to be mathematical reasoning. On the higher paper, 30 marks are going to involve some sort of problem solving. 20 marks are going to involve mathematical reasoning. Now, you don't need me to tell you that students find, particularly foundation students, find reasoning and problem solving difficult. So that could be another criteria which you could, to decide whether to put a student in for foundation or higher. So half the higher paper, and that also applies to Spec B, is going to involve problem solving and reasoning. Reasoning questions, problem solving questions, the assessment objectives are embedded within problem solving and reasoning. So out of those 100 marks, 60, 25, 15 for number and algebra, space, shape and measure, data handling, 50 of those marks are going to be on problem solving and reasoning. And if a student is going to aspire to the higher grades on the higher paper, they have to be able to handle problem solving and reasoning easily and competently. On 4MB1, so let's have a look at the overview on Spec B. Obviously externally assessed, there is no modular for MB1. It's not modular, end of. It's available summer and November. It used to be summer and January, but that's changed to November now. Paper 1 is 1/3 of the total international GCSE. Paper 2 is 2/3 of it. So whatever a candidate scores on paper 1, so 1/3 times that plus 2/3 of whatever they score on paper 2 becomes the final mark. On 4MB1, on Spec B, we've got questions on number, sets, algebra, functions, matrices, geometry, mensuration, space, shape and measure, vectors and transformation geometry, trigonometry, and then statistics and probability. In the same ratio, number and algebra is 60 marks, space, shape and measure, AO2 is 25, data handling and statistics, 15 marks. Let's have a look at matrices. What students need to learn. I've said it before, I'm going to say it again. Every teaching colleague should have a copy of or access to a copy of the spec. As I say, I was old-fashioned, so I used to print them out and have them at the side of my desk because I used to scribble in them and make certain comments about, you know, things that needed to be emphasized and whatever. And even though I had been teaching a fair old time, I've been teaching 25 years almost, when I retired, I still checked the spec to make absolutely sure that I had covered everything. Not one of my students was ever able to say to me, Joe, you sent me into that exam and I didn't know this, that, or the other. It happened to me once. When I first started teaching, my head of department said, don't bother teaching them trigonometry, they won't understand it. It was a bottom set group and they were doing intermediate GCSE. Well, one girl had a tutor and her parents, and you know, obviously the tutor told her, told the parents complained. I didn't get into trouble because my head of department backed me up completely. He told me to do that. But then when I thought about it, and I thought, well, what would I have thought had that happened to one of my children? And I'd have felt exactly the same way. You know, you've got no right not to teach. And from that point on, no student of mine ever went into an exam without having me delivered the entire course. Please also remember what I said. If the word is used in the spec, we can use that word in the exam, can and will. So students need to be very, very familiar with everything that's in here. And as in Spec A higher tier, problem solving and reasoning forms 30 marks and 20 marks of each paper are going to be problem solving and reasoning respectively. Remember, these are embedded within the assessment objectives AO1, 2 and 3. Right, here's a reasoning question. So, now this is that's a proof. And it proved that triangle MCB is congruent to triangle NBC. So clearly, candidates need to understand the word congruent, although anybody taking Spec B, I can't imagine that they would not understand that word. And this is reasoning, and here is a problem-solving question, because it's not obvious what to do. So this is question 27, it's 5 marks, so it's going to be on paper 1. In fact, I think this 3 marks, it's also going to be on paper 1. Now, this is question 10. This is question 27. The fact is that this is going to be right at the end of paper 1. So the equation of a curve is y is equal to a plus bx raised to the power of -1 plus 9 minus 9 x to the raised to the power of -2, where a and b are constants. The maximum point on this curve is 3, 4.3, 4.4. Find the value of a. And this time, I am not going to discuss them, because activity 3 is asking you to work through the 2 previous questions, make a note of anything that occurs to you. And once again, we'll just stop for about 3 or 4 minutes. Okay, just before I move on, I'm just going to address one question, because one delegate has just asked, can students sit for both papers in the same exam series if they're following the modular route? And that's just a benefit from resitting one paper if needs be. Yes, I believe you can do. I will give you the contact number for the advisor at Pearson, who is probably the best person to write to about that. And I'll give you that at the end. But I believe that certainly is possible. Right. Okay. So, a suitable plan to communicate the answer. Well, we know that MN is common to both triangles. MC and NB are equal in length. And then we also know that angle CMN and angle BNM are equal. So we've got a situation, we've got 2 sides and an angle, and we can conclude that the 2 triangles are congruent. With a proof or a show that, it is important that a conclusion needs to be written, because the examiner needs to be convinced that the candidate knows that they have reached a conclusion. So there needs to be a formal in the sense that there needs to be a conclusion. And for this one, I mean, this is a problem-solving question because it is not obvious from there by any stretch of imagination for a casual read-through of the question that candidates need to differentiate. So a suitable plan for this: use the fact that y is equal to 4.4 when x is equal to 3 to get one equation in A and B. In fact, I must admit I did that right at the end. My first step was to differentiate, set equal to 0, substitute in 3 and find B. I found B to be 6. And I found that, therefore, just by substituting back, because I didn't want to bother with simultaneous equations, because I knew that if I differentiate, that the A is going to disappear, and I'd have a linear equation. Well, it's not a linear equation, but it ended up as a linear equation in just B. So I thought that was easy enough. I thought it was slightly better to do it that way. I think this is slightly more complicated because you have to do simultaneous equations if you do it this way. As I say, I didn't do it my way. Right. Okay. How do I make sure I cover all the content? Specification. We've got year plans. Now, the specification is a crucial document that you have to have. You've got to be using that. The year planners, we produce year planners. Those are optional documents. And we produce lesson plans. And those are optional documents. I have to say that I had a complete set of Pearson lesson plans together with in the same folder as I had my spec. And of course, you will have your schemes of work, school schemes of work, and they are published in Word deliberately so that you can copy and paste, you can edit, you can do what you like with them, but they're published in Word deliberately to help you so that you just adapt it straight to your school with minimum effort. We also have approved textbooks. I'm very proud of the fact that I was series editor and I authored 4 of the textbooks, international A-level textbooks. I authored P2, M1, FP1 and FP3. I'm quite proud of that little project. And anecdotally, I remember when the first textbook came out, I took a photograph of it and sent it around my family WhatsApp group. And my older son, he's quite witty. He said, "Well, you know, Dad, you're not going to make the New York Times bestsellers list." He said, "But it's still pretty cool." So, and I was quite proud of that. Having said that, the textbook is not the specification. The textbook is not the scheme of work. Having said all of that, it's the specification is the go-to document. Right. In the spec, it's got this right at the beginning. The Pearson Edexcel International GCSE in Mathematics qualification enables students to develop their knowledge and understanding of mathematical concepts and skills, concepts and techniques, acquire a foundation of mathematical skills for a further study in the subject or related areas, enjoy using and applying mathematical techniques and concepts, and become confident in using maths to solve problems, appreciate the importance of maths in society, employment, and study. Now, I will admit that I did have problems convincing my hairdressers at college that they were ever going to use collecting like terms when they were in the salon or using Pythagoras. That itself was quite a challenge, I can assure you. But it was far easier convincing carpenters and electricians about mathematics. It's a little bit harder with hospitality, health and social care, and hairdressers. But nonetheless, they need to, the fact is, as I used to say, work with me because this is going to help you, and you don't know where you're going to go in your future lives or careers. So once again, the spec. This is page 21, I think, of the spec. This is foundation, the first page of the foundation spec. I'm going to repeat it again. Remember what I said. If the word is in the spec, we can use it in the exam. So under 1.2a, understand and use equivalent fractions, simplifying a fraction by cancelling factors. 8/60 is 2 in simplest terms, in simplest form, lowest terms. If a candidate doesn't understand, knows how to do that, but doesn't understand, has never been described as lowest terms or simplest form, they're not going to be able to answer the question. So use terms, odd, even, prime, factors, multiples. Identify prime factors, common multiples. Everything needs to be known. Everything. And all this needs to be known by higher students. So we've got the content that must be taught. These could be well, they certainly were my assessment objectives. So I used them. And here we've got notes exemplifying or just clarifying the content. That's one document. The scheme of work. We publish schemes of work 1 year and 2 year and 3 year. College, we did it. We had 32 weeks to deliver foundation GCSE, which is, we used to have about 1,200 students doing that at college, and about 1,200 16 to 19-year-olds, and about 300 or 400 adults doing foundation GCSE for various reasons. The oldest person I ever taught was over 80, which was interesting. Yeah, we used to have a small group of about 100 doing higher, but very, very few. Right, here's an example of a lesson plan. And I must admit that even though I flattered myself that I was an experienced teacher, I did find this very useful. So degree of accuracy, identify upper and lower bounds where values are given to a degree of accuracy. Solve problems using upper and lower bounds where values are given to a degree of accuracy. So then we've got possible success criteria. We have opportunities for reasoning and problem solving. 25 marks are problem solving, 15 marks are reasoning on foundation, and on the higher it's 30/20. It's critical that students are able to apply problem solving and reasoning to pretty much anything. And of course, the common misconception, which I used to find very common. In actual fact, I used to teach upper and lower bounds using inequalities in the end, because it's easy to convince a student. It's easy to convince them that, for example, 10 centimeters to the nearest centimeter, the lower bound is 9.5. Well, we know that because that rounds to 10. But if you tell them the upper bound is 10.5, a lot of them write 10.4, 10.49, 10.499. But I used to use, I learned to use inequalities where the length L was greater or equal to 9.5, but less than 10.5. And that way, I convinced them how to use the correct values. I hasten to add that is something I saw somebody else doing. All of my best ideas, or some of my best ideas, certainly I nicked off somebody else. But these lesson plans I found personally to be extremely useful. This is the year planner. Now, I put together the year planner for Further Pure Maths, International GCSE, 4PM1. So these are not set, the number of teaching hours are not set in stone. Absolutely not under any circumstances. They're what somebody with a fair amount of experience thought. Doesn't always work that way. But by going through all of this, you will know that you have covered the whole course. Remember, the title of this little bit is, how do I ensure I cover the content? You need to use the documents that we have: specification, lesson plans. These are the optional documents of the lesson plans, year planner, to make sure that every single little corner of the specification has been covered. This, again, is a useful document. Very useful. Right. Mark schemes and examiner reports. Two separate things. Both very important for teachers. Do mark schemes first. So what is a mark scheme? Well, a mark scheme is the answer to the question, firstly. And they give the range of responses the student might give. We can't count for every single response a student we might see in an exam. There is a mechanism if an examiner sees a very unusual response, then the mechanism that we've got is that the examiner then sends it or escalates the response to their team leader. We call it sending to review. And then the team, because I personally, as a principal examiner, my teams, I don't expect an examiner to sit there looking at an unusual response and giving them the responsibility of making a decision. Is it worth the mark? Isn't it worth the mark? You know, things like this. So my instruction would always be send to review. Escalate it to your team leader. Your team leader can spend 10 minutes looking at it, whereas I don't expect you to do that in the slightest. They do advise markers to look out for common errors. So, for example, let me use an example from my level, because it's just this second come into my head. So we've got log A minus log B. And candidates are going to simplify, and they should write log A over B. But what some candidates do is they write log A over log B is equal to log A over B. That would not score the marks. That's a conceptual error. Even though a student might get the correct answer doing it that way, for that particular mathematical step, they would not score the mark, because that is conceptually is just not right. And examiners use the mark positively. We call it positive marking, and we look to reward marks for correct work seen. We do not penalize candidates for what is not seen. I really, really don't like it when I hear somebody say, well, would you knock a mark off for that? We don't knock marks off for anything. We award marks. We do not start off with 100 marks and start chipping away until we've reached the final score. We start off with 0 and we award marks. We add them for every single thing that we see. Mark schemes are written at the same time as the question. If in a question there are two separate mathematical steps that have to be done, then it would have 2 method marks. to reward. Correct mathematical work is always rewarded. Right. So we have M marks. M marks are method marks. In the case of a single method mark, the whole method must be complete for the award of the mark. Solve. X squared plus 3x plus 2 is equal to 0. Now I would suggest that's probably worth 2 marks. So it's x minus 2, x minus 1, so x is equal to 1, x is equal to 2. So that sort of question, the whole method would have to be complete to score the method marks. Method marks are nearly always, I have to be careful because some method marks are dependent method marks. Method marks are nearly always follow-through marks. So if a candidate does some work in part A that's incorrect, and they don't score any marks in A, but they use what they've got in A correctly in part B, then the method marks in part B will be scored. They will be awarded. A marks are accuracy marks, and that mark is awarded for a correct answer or correct part of an answer, and the A mark is completely dependent on the corresponding M mark being awarded. So if the M mark is not awarded, if it's M0, it is automatically A0. Without having to look further, it is automatically A0. If a correct answer comes from an incorrect method, in which case the M mark is not awarded, the A mark will also not be awarded. Now, in the example that I gave you about the logs, obviously logs are in A level, not in GCSE, but as I say, it's an example that just flew into my head at the time. If somebody wrote log A minus log B is log A over log B, and then they wrote log A over B, they still would not get the mark, because that is correct, that they would get a correct answer using an incorrect method. There is no such marking combination M0, A0, M0, A1. It's not possible. B marks are independent marks. They're awarded for a correct answer seen, and they're used for write downs, for transformations, where the answer isn't the result of a calculation or a method. For example, the minimum point of a curve y is equal to f of x is 4, 5. Write down the coordinates of the minimum point under the transformation f of x minus 5, or something like that. That's a 1 marker. Typically, it depends on the paper, but the bulk of the marks will be method marks. So, when constructing a mark scheme, the exam writer will be thinking about the overall strategy a successful student will use to answer the question. And I have to tell you that we're always surprised by the the ingenuity some candidates use. And some candidates use, we see some very, very clever responses. Please rest assured, I'm going to say this here and now to be absolute, to make sure that you're completely clear on this. If a student uses a method to solve a question that is more advanced than the one in the specification, and the mathematics is correct, they will receive full credit. Always, every time. Because if a student, I suppose it applies more to A level than to GCSE, but if some students are resitting a GCSE and they're perhaps doing Spec B or further pure maths, then they will be subject to more advanced methods. If they use more advanced methods, they will always get full credit. Credit from correct maths. So here, this is our roof support. We have to find CM. So finding the length of CM using Pythagoras, which I did earlier, it's 3√5. Find the total length of all 4 lines. Now we need to round up the total length irrespective of what it is. It doesn't actually matter if it had been, I think the total length, it's actually 3√5 is 6.7. Even if it had been 6.1, it would have still had to be rounded up to the or rounded up to the nearest higher integer. So multiply it by 2150. Write down the answer. Show you're working clearly. So let's have a look at the mark scheme for this. We've got a mark scheme there. No, we haven't got a mark scheme. I thought we had. Sorry. So, okay. So there's 2 marks to find the length of CM. That's going to be M1, M1A1. Then it's going to be the total. Oh, I'm surprised at that. I don't think that's quite right, actually. I think to find the length of CM will be 1 mark. Finding the total length of all 4 lines, because the student has to decide, has to know that they've got to round that 6.7 up to 7. That's going to be another mark. Then multiply the total by 21.5 and write down the answer. So I think the mark scheme would be M1, 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 A1. Let's have a look at this one. This is 4MB1. A regular polygon has n sides. Each interior angle of the regular polygon is 2x. Each exterior angle of the regular polygon is x minus 54/2. Find the value of n. Do we have a mark scheme for this? No. So, the strategy for this. Set up an equation using the sum of the interior angle and the exterior angle. It's actually very important that students do understand exactly what the exterior angle is. Solve the equation to find x and use the found value of x and the exterior angle of a regular polygon, 360 divided by n, and then write down the answer. So each step, each mathematical step has a mark attached to it. Oh, here it is. Okay, so we've got M1, 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 A1. Right. 2x plus x minus 54/2 is 180, or any equivalent to that. OE means equivalent or equivalent, and that's M1. Then we solve the linear equation, and we find that x is equal to 82.8. Another method mark. Then we substitute the 82.8 back into the exterior angle. 360 divided, so 2 times 82.8, or just do solve the linear equation here for n. N is equal to 25. Clearly, if a student does not get an integer answer, then they have made a mistake, and they should be aware of that. Now, we've got 82.8 here in brackets. in inverted commas. Now, the reason why that's in inverted commas is that if they take that value there, now notice that the M1 is for the equation. It's not for 82.8. If they just having that equation is sufficient for M1, so whatever value they've got there for the 82.8, if they use it correctly here, they will then score that M mark. Okay, I'm going to start getting a little bit of a move on because we've got half an hour left. So senior examiners will use the content and assessment objectives to devise the questions and the mark schemes. So the exam paper will not only satisfy the percentage of content, but also the percentage of questions for each grade. On a foundation paper, it's 20 marks plus or minus 1 for grade 1, 20 marks plus or minus 1 for grade 2, etc. Right, so I don't know whether this is a 4MA1 or a 4MB1 question. It could be either. Show clear algebraic working. Not sure what the answer is, whether you could guess it. They normally write that in case of possible guesswork. Right, here's the mark scheme for it. So let's have a quick look. Let's go back. So clearly we've got to find get to form some sort of linear equation, and then initially, right, let's see what to do. So the first M1 is for writing fractions over a common denominator, or for a method to remove the denominator by multiplying each term by 20 or 100, etc. So we end up, the first step is to remove the denominator. Second M1 is to remove brackets and fractions on the left-hand side in an equation with no more than one error from expanding on the numerator, or an equation with terms on the numerator or fraction simplified with no more than one error. So notice that we are actually allowing an error here. So they make an arithmetical error. We would not allow a conceptual error. It would be an arithmetical error. And then final M1 is for solving the equation, and the final answer is 1.2. The A1 or equivalent, depending on all the method marks being scored, all of them. It is simply not possible to score an A mark if the method marks are not scored. Here's some alternative methods. So writing fractions over a common denominator could be two fractions, or for a method to remove the denominator, etc. So this describes what a student has to show to get the first method mark. Again, keeping track of the next stage of the different methods shown for the method mark. So we have alternatives, but we can't put in every single conceivable alternative. Sometimes we actually put a mark scheme, a general case for solving. Certainly in something like vectors, where there could be several paths, but actually the principle is doesn't change. And this is the final stage. Note at this stage the working must be accurate to earn the M mark. So the final M mark, we've got a linear equation, terms in X on one side, a number of terms in a correct equation, and in actual fact, what we need to reach is this, as told us by the mark scheme here, and 1.2 A1 or equivalent. So we would obviously accept 6/5, which is absolutely fine, dependent on M1 or 1 1/5. They're all equivalent, so it's absolutely fine. Okay, so activity 5. Now, hopefully, you do have that. Right, so activity 5. Okay, I'm going to just get rid of that because you don't want to say that. We've seen this question before. It's the roof support. Seen it twice, I think, so far. So the question is the roof support. So I'm looking at, oh, the pages aren't numbered, but I'm looking at the delegate booklet. And on activity 5, we've got the roof support, we've got the mark scheme underneath, and then there are 3 student attempts. And what I'm going to do is I can't give too much time now. I'm just going to give 5 minutes, and I'd like you to all please have a look at the mark scheme and have a go at marking exemplar A, exemplar B, and exemplar C. There's 3 different answers. So can you have a look at marking those, please? And I'm going to give you, as I say, 5 minutes for that. Look, I don't want those. That would be really angry.
Hello, excuse me. Where are the exemplars? Because I can't find them on the document.
Right, there should be. Have you got a document called delegate booklet?
Yes, I've just seen activity 5, which is slide 82. And then when I scroll down, it doesn't, it says the exam paper, the formula sheet, that's it. And then examiner reports.
So what you should have is question 11. The diagram shows the roof support. Have you got that?
I can't see it.
Oh, it's going to be a very long 5 minutes for you then if you do that. I am sorry about this. I don't know what's happened with this. You should have on the first page, the pages aren't numbered, not that that matters. You should have a copy of the question, the roof support, and you should have underneath that, there should be a mark scheme which has got the 4 marks, M1, 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 A1, and then it's got 5 genuine candidate responses, which are written they're very neat actually, uncharacteristically neat if I'm honest, and you to mark. And if you haven't got that, and I do apologise. I'm not sure what's happened there.
It's not here.
Yeah, sorry about that.
It's not in here.
I'll try and get after the end of this. I'll see if we can sort that out and at least send it to you belatedly. As I say, I'll do.
Someone said it's on page 8. Page 8. Okay, so we have to go back up to page 8. Let's see.
So it's 1, 2, 3, 4, 5, 6, 7. So I've got on page 7 is the actual question and the mark scheme, and page 8 and 9 are the actual student responses. And you haven't got any of that.
I've just scrolled up to page 8.
You should have some student responses. You should have at the top of the page exemplar A, and in very neat handwriting, 9 squared minus 6 squared is x squared, which is a correct application of Pythagoras.
I can't find it on this one. Perhaps someone else can direct us, because I've just gone back to page 8 and I can't see it there.
Oh, I'm really sorry. I'm going to stop it in a second anyway. I do apologise. I'm going to ask Hansel if he can send it to you so that you can belatedly, at the very least, have a look at it after the event.
Oh, apparently there are 2 documents. There's a Word document. Oh my goodness. Okay, I'm looking at the PDF. I don't. All right. Okay. Thanks
Right.
to Colleen. Thank you. All right. Okay.
Thank you. Okay, I did say 5 minutes, and it's 22, and we've got 20 minutes, and there's still a fair bit to do. So, on page 8, the first one, exemplar A, they've used Pythagoras correctly, M1. They found 6.7. Then they found the total and multiplied it by 21.5, and they need a new calculator because they have, in fact, done a completely correct method. They either need to go to Specsavers or they need a new calculator because it should be 795.5. So that is definitely a typo, which is a bit unfortunate because this candidate has got 3 out of 4 marks. The next one is exactly the same. But this time, they've added up 12 plus 9 plus 9 plus 7, and instead of using a calculator, they did it in their heads, and they got 47 instead of 37. But the method is exactly the same. So the method is completely correct, so they get full marks there. The third one is a little bit more interesting. The Pythagoras is incorrect, so they lose the first 2 marks, but they do add together their length for CM, and they do multiply by 21.5, so they do get that M mark there. Right. The exam paper. The time to look at the front of the exam paper is not on the day of the exam. No student is ever going to read this, and it's often overlooked. I'm going to go through these bullet points. Use black ink or ballpoint pen. Every script is marked online. If it isn't in black, it won't be seen. Having said that, if we can't see it, the script would be extracted. We would do everything we possibly could to mark scripts. Fill in the boxes at the top. Well, that's obvious. Answer all questions. If a candidate doesn't answer questions, what's going to happen is that they're going to allow the examiner to earn marks for doing nothing. Because if they just leave it blank, then an examiner is going to be paid to put a row of zeros in the score box. The next is really crucial. Without sufficient working, correct answers may be awarded no marks. Show all working. Every time, answer the questions in the spaces provided. We provide more paper than candidates need. So there's always plenty of papers. And on Spec B, candidates might be given 4 sheets of paper, and they probably can answer the question in 1.5. And that kind of worries them. There's nothing to worry about. We always give more paper than they need. Calculators may be used. Quite often in the UK, and I used to read exam reports, it's clear that many candidates did not use a calculator in this paper. And you must not write anything on the formula page. It will not be scanned. It will not be seen. So the total marks is 100. The marks for each question is shown in brackets. And read every question before you start to answer it, and check answers at the end. Read this before the exam. Make sure students are familiar with everything that's on it. So I've gone through everything here. So I've already gone through that. If there are 100 marks to be answered in 120 minutes, it's roughly 1 mark a minute. Some will be faster, some will be slower. There is time to answer every question. Right. I'll share a little story. It'll take 30 seconds. When I was at college, and we had to give at the very start of the year, academic year, we gave a past paper for students to do to gain a baseline. There's one lad was sitting there, just gazing at this piece of paper there, that one there. I went round and I went round again, and I said, "Are you all right?" And he goes, "You know, Joe, I don't answer this. I don't understand this question." And I thought, this lad has never been told what the formula sheet is. And from that point on, which is something I realized that I should have taught before, I used to go through with students, go through with the formula sheet on the board, go through questions and say, where can we use the formula on this piece of paper? In which questions would we need to use a formula from here? And the irony of it was that I think question 2 or 3 across the page was of squared paper, draw a picture of a trapezium, and there's one there. The formula page makes sure that students are very familiar with what is on here and how to use it. On Spec B, we do not give a formula sheet. Any formulae that are needed are given, and the ones that they're expected to know are in the specification. Right, examiner reports. I can't really overstate how important these are. So they highlight the areas for development that schools need to concentrate on, and some topics go over and over again. And I'll tell you now that I used to make my sixth formers read them. So these are the mistakes that are made year on year. Don't you be the ones to make these mistakes. So just a couple of things. So this is a question. Factorize fully 50g squared minus 18. So a student has to recognize that it's the difference of 2 squares. The majority of students were not able to gain the full 3 marks. The most common scores were 0 and 1, with 1 mark being awarded for 2 taken out as a common factor, or 5g plus 3, 5g minus 3. Some students found a difference of 2 squares using surds, which, like that, we scored 0. As well as this is a summary at the end. To enhance performance in future series, centres should focus their students' attention on reasons in geometric problems, show working, coordinate geometry, histograms, unstructured trig questions, application of bands, questions involving algebraic proof. Honestly, these exam reports are really worthwhile to read. Here's another example. I'm running short of time now. I'm not going to read this all the way through, but hopefully you get the picture. You get the picture about how important these are. When I was at school, our first at the beginning of the year, we would read the examiner reports, we would have a look at Results Plus, and we would then read the exam and say, how these are mistakes our students are making. What are we going to do about it to put it right? Okay, I am not going to do this, but I am going to do this. Good examination technique. Practice using a whole paper and understand how it's laid out. Understand the importance of the mark allocation. Read the whole question first. Remember, problem-solving questions, the information is given in order. Show what's in your head. Student can only show what's in their head by writing it down. The examiner doesn't know otherwise. And can I just, It's sometimes, well, it's usually obvious which is a girl's work and which is a boy's work. Sorry, gentlemen, for sounding quite sexist, but you don't need me to tell you that. Work neatly and in an orderly manner. We will always do everything possible to give as much credit as we can for correct work, but don't make it difficult for the examiner. Now, walking, talking mocks. This is really good. I've been doing this for years, especially with low ability students. You talk about what I used to do. I mean, it's not the first thing isn't possible. Sit students in the exam hall will do where they will do their exam, preferably in the same seats. Well, logistically, that isn't possible. Students are given an exam paper, which is a pass paper, and then all discussed together questions 1 to 6. What do we need to do in question 1? What do we need to do in question 2? What 3, 4, 5, 6? What do we need to look out for? And then they do them. When they've done that, then we discuss 7, 8, 9, 10, 11, 12. And then we discuss those as a group, as combined. How do we do that? And then they practice keywords, instructions, how to do things. Now, I used to do this and I found it very successful with lower ability children. And they really liked it, and they felt that they had learned a lot from it. Right, in the last few minutes, I'm going to talk about support. I was at a face-to-face session in Birmingham, actually. I'd only been teaching 2 or 3 years, and I was sent to a course, and I was sitting there, and the presenter from Edexcel said, "Well, why do you use Edexcel?" And somebody said, because of the resources that you've got. The resources Edexcel have are amazing. I've been talking about it the whole time. The specification, and SAMs, the go-to documents. Aside from that, we've got course materials, specification and SAMs, exam materials, past papers, teaching and learning materials, teaching support and training, seminars like these, Maths Emporium. We've got an international subject planner, Mark Heslock. He's brilliant. If I email him, he usually answers within a couple of hours. So we've got the spec, past papers, teaching and learning materials, past training content. Results plus. I'm not saying that absolutely everything is useful on it, but the things that are useful are exceptionally useful. So I used to download a student's performance on their papers, which was particularly useful at college where they were repeating sometimes for the 2nd or 3rd time. We saw where they were good. We saw where they went wrong. I used to print it out for them. This is what you need to concentrate on. So identify potential topics, skills, and types of questions where students may need to learn further. See actual scores for each exam question for a student, class, or group. Some things I didn't use because you could do a comparison between other schools. Well, I wasn't really interested in what other schools are doing. I was only interested in what my students were doing. But there's plenty there, and what was useful was exceptionally so. So, results plus. Student takes paper, exam papers are scanned. I've already told you. It's only in very rare cases does the examiner actually see the physical paper that a student wrote in. And those are, for example, in large scripts. I've marked scripts in Braille, and large scripts. I've received scripts on A3, A3 size, but the vast majority is all marked online. Examiners mark papers online. The scrutiny on marking is intense. Every examiner that is marking Edexcel papers has to qualify to mark for every single series. I am considered to be a senior examiner. I'm chair of examiners on 3 specs. I'm a principal examiner on A level. If I was offered a contract today to mark foundation GCSE for MA1, I'd have to qualify like everybody else. And if I don't qualify, I don't mark. It's as simple as that. And then when examiners are marking, there is considerable scrutiny on what they do. Exam Wizard. Anybody who's used Exam Wizard doesn't need me to tell them how brilliant it is. You can create a mock paper, a homework in seconds, literally, to create a homework on arithmetic series. Pick a topic out of the blue. Arithmetic series, 10 questions, past questions, an arithmetic series. Put them together, download it into Word. So I could perhaps edit it, I could scaffold it to make it easy. I could get the exam reports and I can get the mark schemes. And it's an amazing resource. You can get this, it's all free. If you're an Edexcel Centre, all this is free. Access to scripts. You can see the scores that were allocated to your students in the exam. And we're the only awarding organisation to provide access to your students' marked exam papers as part of your qual fees. We do not charge for that. And what I found with access to scripts was that when we gave access to scripts now 6-7 years ago, the inquiries about results, the appeals dropped dramatically when teachers saw that their papers had indeed been marked correctly. So, paid resources, textbooks. You don't have to buy our textbooks. We now have textbooks for the modular and linear routes. The modular ones have just been finished, so we don't have to have textbooks for the modular and linear. Or you don't have to buy our textbooks, but they are curriculum matched. They do have problem solving. They do have reasoning. Everything like that is signposted. They're fully reviewed and revised and our curriculum matched. And there's a picture of Mark Heslop. He's absolutely brilliant. Now, he heads up a team teaching maths at Pearson.com. So it's not just him. But if I send him an email, I mean, I correspond with him fairly frequently on various things. But if I send him an email, I get a very quick reply from him. Right, so thank you very much indeed. I am going to now stop 2 minutes early because I'm just going to go through the chat to see if there's anything I need to answer. Some people have said, thank you for the presentation. You're very welcome. I'm glad that you found it useful. Somebody's listening. All right, somebody's listening on their phone, can't hear the, is there assessment builder like Cambridge Testmaker? Yes, we've got Exam Wizard. I don't know what assessment builder is on Cambridge Testmaker, but we do have Exam Wizard, and Exam Wizard I found to be absolutely amazing. Lots of people saying thank you, and I'm going to say thank you very much for your attention today. Thank you for making the effort to come. It is 1 o'clock. So somebody says, thank you, Mr. Joe. It's Joe, it's not Mr. Joe. But thank you very, very much indeed. I really, I'm very grateful for you for making the effort to listen to me, and I hope it was useful to you. Hansel, are you going to say anything at the end? No, he's not. Okay, so thank you very much indeed. Oh, sorry, there's for the modular research Unit 1 and 2. I am not sure if Unit 1 and Unit 2 can be done in the same window. Could I suggest to you that you write to Mark Heslop and ask him? Thank you very much indeed. Okie doke. Hansel, are you going to stop the recording now?